Friday, we had a lot of steps to get to where we got to. So if we were given points, we first had to take our points and go to the component form. So to remember to find component form, it's terminal minus initial. Once we had our vectors in component form, then we calculated the cross product of them. We also talked about the fact that we could multiply it by any scalar, and it would also be another perpendicular vector. Then we said, okay, so we have this vector that's perpendicular. Let's find its magnitude. That's going to give us the area of the shape created, which is a parallelogram. And then if we wanted to find the area of a triangle within the parallelogram, because there are two, we can either think of it as multiplying by 1/2 or dividing by 2. So that's where we landed, okay? The only thing I'm going to add today is to say we want to find the volume. If you already have the area of the base, so the base is the parallelogram. So if I have the area of the base, what do I need to multiply that by to get volume? Height. So I only need one more thing, one more piece of information. Do you see why I'm saying the notes are so short? So once we find this area, all I have to do is multiply it by the height to get my final answer. So look down here, this is going to be our formula, and let me zoom in on that because that's tiny. So the volume is going to be, we found the cross product, we went through and found the magnitude of it, and then after we did all of that, we're going to multiply it by the height, because then that's going to give us the volume of the whole thing. Now, the question becomes, what if the shape that we're given is all coplanar, meaning all the points are on the same plane and it has no height? So if I give you some points on the ground and no height, what would you tell me the volume of the parallelogram is? Volume. So if all my points are on the floor, here's a parallelogram on the floor. If I want to find the volume of the parallelogram, what would my volume be if all the points are on the floor and there is no height? Zero. Okay. So sometimes, yes, rocked it out. All right. So how do we know? Listen. How do we know if everything is coplanar? Because the volume is 0. So everything is coplanar when our volume is 0. If we get a volume of like 12, then we know we have some depth to it. Okay, again, I need you listening. All right, so we also call these, as we're going through it, multiplying by a scalar triple, because the height that we multiply by will be a scalar triple. All right, let's see. We want to find, I'll wait till everybody's done talking. We want to find if we have volume, and if we do, we want to calculate what the volume is. So kind of like always, we don't have any information given because the formatting is weird, so I'm going to give you your vectors. So let's say we have vector A, and it is 1, -1, 0. And then we have vector B, and it is -1, 0, 1. And then we have vector C, and it is 0, -1, 1. Let me check all my signs. Make sure I feel good about how I just wrote that down. Yes, I match. Okay. All right. So these are my 3 vectors that I have. The first thing that I want to do is find B cross C. Or sorry, A cross B. No, which one do I want to do? Let me read my directions. Yeah, we want to do B cross C. And then A is going to give us our height or our depth to our figure. So we're going to start with B cross C to find the parallelogram. And then we're going to have to do the dot product with A. Here we go. B cross C. I'm going to put them into a matrix just like we were doing on Friday. So -1, 0, 1, 0, -1, 1. So if I'm finding B cross C, remember we start by covering up. I'm going to cover up the first column. 0 times 1 is 0 minus -1. All right, cover up the middle column, and remember we go opposite. 1 times 0 is 0 minus -1. Cover up the last column. -1 times -1 is, and then minus 0. So when we get our final answer, this ends up being plus a positive. So I get 1, and then another 1, and another 1. Super exciting vector. All right, so I'm here. This is going to tell me about the parallelogram. If I were to take the square root, or if I were to take the magnitude, it's going to give me the area. So the next thing I'm going to do is calculate the dot product. So in order to find the volume, I have to do the cross product, and then once I find that, I take the dot product with A. So again, this is me going through the process of getting that extra dimension of having volume. So I need to take these two, and then I need to find the dot product of the two of them. So take your components and multiply them. 1 times 1 is, yes, negative, bless you, -1 times 1 is, 0 times 1 is 0. What do I get when I add that up? 0. So it says find the scalar triple. This is the value of the scalar triple. The scalar triple is the same as finding the volume. So 0 is my scalar triple. So are the vectors coplanar if my volume is 0? Yes, everything lives on the same plane because I have no height to it. So number 1, this is the answer to part 1. Number 2 would be, are they coplanar? Yes. So do I have a volume for part 3? I don't, because the scalar triple was 0. All right. Moving on to part B, we're going to do a different one. This one's not going to end up being 0, but we got a lot of 1s again. 1s and 0s and -1s. All right, vector A, new problem. New problem, but a lot of the same characters. Vector B. Vector C. So again, we're always going to find B cross C and then deal with A as thinking about the third one being our height. So let's find B cross C. And honestly, you could probably do this without putting it into a matrix, because isn't it kind of already set up as one? I think I'm going to be a little lazy and just cover up, because I think we're already good. It's already kind of lined up. So -1 times 1 is -1, right? -1 is -2. So -2 is my first component. So again, I covered these up. -1, -1. Cover up your middle column and go backwards. So normally we go doot doot. We're going to do the opposite. We're going to do 1 minus 0, which is just 1. And then I'm going to cover up this one. 0 minus -1. Just +1. Okay, now we're going to find the dot product of that with A. So take A. A was 1, -1, 1. And we're going to find the dot product with -2, 1, 1. So I'm taking the dot product of those two. -2 times 1. negative 2, plus negative 1 times 1, plus 1 times 1, 1. All right, so these kind of cancel their way out, and I get negative 2. Is it coplanar if I get a number other than 0? No. So this is my answer for part 1. What is the scalar triple? It's 2. Are they coplanar? No, because I got a number other than 0. The only time we write yes is if this part 1 is 0. Then it says for part 3, we want to find the volume. So the volume is when we introduce that magnitude piece. So when we got our answer here, we ended up getting negative 2, yes? So we're going to find the magnitude of that number. So if I take negative 2 and square it and then square root it, what do I get? Should be positive, right? Because squaring it will be negative 2 times negative 2, which is 4. And then when I take the square root of 4, I get 2. So 2 units cubed is my volume. Because would a negative 2 make sense for volume? My cup holds negative 2 units of water. No, units cubed. That wouldn't make any sense. That'd be like a bad science problem. You're like, I did it. Volume's negative 2. No. So you have to make sure you find the magnitude when you're done. Okay. I want to make sure I have the correct homework.